Hello guys, welcome to RECode 3, an event conducted by Coding Club of PSG College of Technology. My name is Vishal and my roll number is 22I372 and I am class of BTech IT G2 third year. I hope you guys remember me from the past videos. The agenda of this video is we will be discussing about two problems and the steps are problem statement 1, intuitive approach of that problem statement and the solution code in Java, and the second problem statement and the tracing with an example and solution code in Java. So let us dive into the problem statement 1. The problem statement 1 states that given an array of integers ARR of size n, the task is to rotate the array elements to the left by d positions. Let us consider a sample input and output. The sample input states that the array value is equal to 1, 2, 3, 4, 5 and 6, where the d value is equal to 2. So the output here is 3, 4, 5, 6, 1 and 2. The next input is array equal to 1, 2, 3 and d value is equal to 4. The output here is 2, 3, 1. Let us see the explanation in the further slides. The intuitive approach behind this problem is, firstly, we have to normalize the d value, since if the d value is greater than n, it results in repetitive rotation, so that we will be normalizing the d value by modulo division it with the n. And then we have to perform three reverse operations. The first reverse operation is from the index 0 to d minus 1, and the second reverse operation is for the remaining elements, which is from the index d to n minus 1, and the third reverse operation is for the entire array, which will give the rotated result. Now let us see the tracing for this example. The input array here is array equal to 1, 2, 3, 4 and 5. The d value is equal to 2. The output should be, since the value is d equal to 2, we have to shift the first two elements from the left to the right. That is, initially the 1 value is lifted from left to and pushed to the right. So the array will be 2, 3, 4, 5 and 1. Next, again we will be rotating it so that we will get the answer as 3, 4, 5, 1, 2. According to the intuitive approach which we saw, we will be performing the tracing for this example. So initially we have to normalize the d value, that is d is equal to 2 mod 5, which results in 2. So then we will be reversing the first d elements, which is from the index 0 to 2 minus 1, that is 1th index. So it results in the array 2, 1, 3, 4 and 5. Nextly, we have to reverse the remaining elements, that is from the index d to n minus 1, which results in the following array 2, 1, 5, 4 and 3. Finally, we have to reverse the entire array, which results in 3, 4, 5, 1 and 2, which is the output needed. Here, when let us consider the d value is equal to 5. In that case, the array will be 1, the output array will be 5, 4, 3, 2, 1, and let us consider the d value is equal to 10. In that case, the answer will be 1, 2, 3, 4, 5, which is the original array. So that during this case, we have to normalize the d values. And the solution code here is, we will be using two methods, one is rotate and the reverse method. The rotate is the base method where we will be calling the reverse method. The rotate method initially has the variable n equal to array.length, and we will be normalizing the d value where d is equal to d mod n, and then the first step is to call the reverse array from the index 0 to d minus 1, and then the next step is to call the reverse array from the index d to n minus 1, and lastly the whole entire array is reversed from the index 0 to n minus 1. So in the reverse array, it is just the swapping of two elements with the use of a third variable. So this results in the time complexity of O of n and the space complexity of O of 1. Nextly, the result in pad portal, which results in the 6 test cases have been passed. So now let us dive into the problem statement 2, which is, nearly everyone has used the multiplication table. The multiplication table of size m cross n is an integer matrix mat, where mat of I cross j is equal to I star j, where the array is an 1 based indexing. So given three integers m, n and k, return the kth smallest element in the m cross n multiplication table. This is the problem statement given. Now let us see a sample test case. Here the m value is equal to 3 and n value equal to 3 and then k value is equal to 5. So that the multiplication matrix will be of dimension 3 cross 3 and we have to return the fifth smallest element. So that initially we will be constructing the multiplication table and which results in 1, 2, 3, 2, 4, 6, 3, 6, 9 row wise. Then we have to flatten this multiplication table into an 1D array and then sort it. This is the naive approach so that it results in 1, 2, 2, 3, 3, 4, 6, 6 and 9. From this array we can return the fifth smallest number, that is the 3. Consider the sample test case 2 where the m is equal to 2 and n equal to 3 and k is equal to 6. So in this case the multiplication matrix dimension will be 2 cross 3 and we have to return the sixth smallest number. So that the multiplication table which we constructed is 1, 2, 3, 2, 4 and 6 row wise. Nextly, according to the naive approach, we will be flattening this 2D multiplication matrix into an 1D array which results in 1, 2, 2, 3, 4 and 6 after sorting. From this array, the sixth smallest number is 6. So now let us see the tracing for this example for a better understanding. So according to the example, consider the m value is equal to 3 and n value equal to 4 and k value is equal to 6. The multiplication table which will be constructed is 1, 2, 3, 4, 2, 4, 6, 8, 3, 6, 9 and 12. According to the naive approach, we will be flattening the 2D array into an 1D array and after sorting it results as 1, 2, 2, 3, 3, 4, 4, 6, 6, 8, 9 and 12. From this, the kth smallest number, that is the sixth smallest number, is 4. But when we are going for this approach, the time complexity is O of m cross n star log of m cross n. But for this time complexity too, the test cases may be passed. But the constraint here is it will lead to a memory limit exceeded error. Why? Because the value of m and n is approximately up to the range of 3 star 10 power 4. So let the value of m is equal to 3 star 10 power 4 and n is equal to 3 star 10 power 4, which results in 9 star 10 power 8. When we are constructing a table from 1 to 9 star 10 power 8, it results in memory limited exceeded array. So we will be moving on to an efficient approach, which is by using the binary search. How come we know that this approach we are choosing? In the question, they didn't give the multiplication table. Instead, they gave the values m, n and k. This is a key point which is to be noted. So from which we are going to proceed now. The intuition for the binary search is, instead of generating the table and sorting it, we perform binary search on the possible values from 1 to m star n. And the key step is counting how many number in the tables that are less than or equal to mid values. The rules are, if the count value is greater than or equal to k, the right is updated to mid, else left value is equal to mid plus 1. So now we will run tracing for this example. Initially, the left value will be initialized to 1 and the right value will be initialized to m cross n, which is equal to 3 star 4 of value 12. And the min value is equal to left plus right divided by 2, which results in 1 plus 2 divided by 2, which gives 6. Now, the number of elements less than or equal to 6 in this table are 1, 2, 3, 4, 2, 4, 6, 3 and 6, and the count is equal to 9. The count is greater than or equal to k, so that according to the rule, the count n is greater than 6, so we will be updating the right value is equal to mid, which is the value 6. And later we will be proceeding with the updated value of left is equal to 1 and right is equal to 6, with the mid value left plus right divided by 2, which results in 3. Now again we will be counting the number of elements which is less than or equal to 3, which are 1, 2, 3 and 2 and 3. which is of count 5, which is less than k. Since the count here 5 is less than or equal to 6, the L value is being updated with mid plus 1. And again we will be proceeding with the updated left value is equal to 4 and right value is equal to 6, where mid value will lead to 4 plus 6 divided by 2, which gives 5. So the number of elements less than or equal to 5 here are 1, 2, 3, 4, 2, 4 and 3, which counts to 7, which is greater than k. That is, the 7 is greater than or equal to 6. So in this case, according to the rule, we will be updating the right value equal to mid, so which leads to r equal to 4. And proceeding this, the left value will be equal to 4 and then the right value equal to 5. For that, the mid value equal to 4 plus 5 divided by 2 is equal to 4. The number of elements less than or equal to 4 in this case are 1, 2, 3, 4, 2, 4 and 3, which again counts to 7, that is greater than k. And according to the rule, 7 is greater than 6, so that we will be updating the r value equal to mid. And after proceeding, now the left value and the right value are equal to 4, which is the stopping condition. That is, when left is greater than r, we will be returning the left value, which is the 4, which is the answer, that is the 6th the smallest number. Now let us see the coding part of this problem. There are two methods, find kth number and count less than equal. In the find kth number, we will be firstly initializing the left equal to 1 and right is equal to m star n. And then until the condition fails, that is left is less than or equal to right, we will be proceeding with the binary search approach. So initially we will be calculating the bit is equal to left plus right minus left divided by 2, and if the count less equal of mid value and the m and n is less than or equal to k, the left value is equal to mid plus 1, else the right value will be assigned with mid. And lastly we will be returning the value left. In the countless method, we will be adding the count, which is equal to math.min of mid divided by I, comma n. Here the min function is used, and I will explain why the min function is used with an example. Let us consider multiplication table where the number of columns is 3 and the number of rows is 33. And in this case, the dimension of the multiplication table is equal to 3 cross 33. So in this case, initially the left value is equal to 1 and the right value will be equal to m cross n, that is 99, that is 33 into 33, and the mid value will be equal to 50. But there might not be 50 counts less than or equal to the value of mid, so we will be updating the value with mid by I, comma n, which results in there might be n number of counts which is less than or equal to mid. And next to this, we will be analyzing the time complexity and the space complexity. As said earlier, the naive approach results in the time complexity of m star n of log of m star n, and then the space complexity will lead to O of m cross n. But according to the approach which we use, which is the binary search, it leads to a lesser time complexity, that is O of log of m star n, and the space complexity is O of 1, since we don't use any kind of extra variables to store the array or any kind of data structures to store the values. And here the m represents the number of rows in the grid and the n represents the number of columns in the grid. And this is the result which I got in the PAT portal. Here all the 6 test cases have been passed, which can be seen, and these are all the reference videos which I saw on YouTube to explain this problem. And for the problem statement 1, you can refer Striver. For problem statement 2, the link has been given which you can refer. And that's it for today's explanation. I hope this breakdown helped you understand the discussed problems. Your support so far has been incredible and I truly appreciate it. If you found this helpful, don't forget to like, share and drop a comment with your thoughts or any questions you have. I have looked forward to bringing more such content, and I hope you will continue supporting me on this journey. Thanks for watching and have an amazing day ahead. Thank you.